This is section 4.7 on page 14. A rectangle is to be inscribed in a semicircle of radius r. What is the largest area of the rectangle that we can have, and what are the dimensions? Your answer will have an r in it, and remember to treat it like a constant. So I drew my picture over here. There's my semicircle. I centered it at the origin, just like we've done before, and I made my radius be r. I also drew inside, because it does say it's inscribed, a rectangle. I described this rectangle by a point on my semicircle, and I called that point XY. So looking at this, I want to, it says largest area of the rectangle, and an area of a rectangle is going to be length times width. So we have area is equal to length times width, and this is what we want to maximize. We are going to have a constraint equation also. And our constraint equation is by that semicircle, which is going to be x squared plus y squared equals r squared. But again, we're only dealing with half of it, and we'll talk about that in a minute. So I need to rewrite my area formula in terms of x's, y's, and r's instead of l's and w's. So going back and looking at my rectangle over here, the height of my rectangle here is y, and that width down here is going to be, this is x, and this is also x, so this will be 2x. So the area of my rectangle is going to be 2x times y. So we have 2x times y, and this is what we want to maximize. So I need to eliminate one of the variables, and to do that I'm going to use my constraint equation, and I'm going to rewrite my constraint equation in terms of y. So we get y is equal to plus or minus the square root of r squared minus x squared. And again, we're only going to use the positive one because we're in the top semicircle. So r squared minus x squared. And I'm going to go ahead and substitute that in over here. And then we're going to have our new area formula is going to be area equals, and we're going to have 2x, and then instead of y, I'm going to rewrite that as r squared minus x squared in the square root. So r squared minus x squared, I'm going to rewrite as to the 1/2, but same thing as the square root of that. And now you'll notice that my area formula is in terms of just one variable. That variable is x. R is just a constant. So think of it as just a number. So now I need to find the derivative. And my derivative is going to be the first times the second, the derivative of the second. Times the derivative of the inside, which would be negative 2x. And then we have plus the derivative of the first times the second. And then simplifying this, you are able to factor out a r squared minus x squared to the negative 1/2. I can also factor out a 2. So I can factor out a 2, and I'm r squared minus x squared to the negative 1/2. And then left over, we have a negative x squared and we also have a plus r squared minus x squared. So simplifying this, we arrive at 2, and it's going to be r squared minus 2x squared all over the square root of r squared minus x squared. And to find our critical values, we're going to set this equal to 0, and that means that we are going to have 2 times r squared minus 2x squared is equal to 0. Solving this, again, r is just a constant, so see if you can work this out and solve this, and you should get x is equal to plus or minus r over the square root of 2. If you need help with those steps, check online at the filled-in notes. So now we have that. We also need to look at where the area is undefined, our derivative area, and it's undefined when we have the square root of r squared minus x squared is equal to 0. And we get that is when x is equal to plus or minus r. And so looking at this, to have x is equal to negative r, x is equal to positive r. Up here we have x is equal to negative r over the square root of 2, and x is equal to r over the square root of 2. So we can cancel out a few of these ideas and say, nope, it can't be negative. We talked about r standing for that radius, and it's unable to be negative. And also, what happens if x is equal to r? Let's go back up and look at our picture. And if x is equal to r, then that means that my x value, my point, would have been out here, and it's not inside that semicircle, so that would also not work. So I'm going to go ahead and cross that one off in addition to it. Again, if you didn't realize, then you would have just gone through the math and it wouldn't have worked out anyways. So the value that we have that we're going to check is when we have r over the square root of 2. For our x value, I'm also going to start this at 0. To test this, it is a little bit trickier because we do have a variable in this. And when you do that, you need to think of r and think of something small, pick something small, substitute it in. And I'm going to leave it as, let's say, r divided by 2, and I'll test that and substitute that into my derivative. That is smaller than r divided by the square root of 2. And then to something larger, I would test, we can do r over something less than rad 2, so it'd be less than 1.4. So we have, you can substitute in r, I'll do what I did on my notes, which was 1.2. And when you do, this is going to be a positive value, so that means it's increasing, and this is decreasing. So increasing, decreasing, therefore we have a max. So max when x is equal to r over the square root of 2. And so it's asking for, in this problem, the dimensions. And so the dimensions are going to be x is what we have, and then y is equal to, and the formula that we had for y was the square root of r squared minus x squared. And substituting in what we got for x, we have r over rad 2 squared. And when you work this out, you have the square root of r squared minus r squared over 2. And if you get a common denominator and multiply by 2 over 2, this is going to be the square root of r squared over 2, which simplifies to just r over the square root of 2. So the dimensions are x equals, and the x value that we had down here is r over the square root of 2, and our y values are going to be r over the square root of 2. I'm going to go to put units on here. Okay, so we have x is equal to r over square root of 2 units, and y is equal to r over rad 2 units. And if we go back up and we look at our rectangle, you'll notice that our rectangle has area, and our area was equal to y times 2r, and our y value is r over the square root of 2. And then we have 2 times our x value here, and our x value here is r over the square root of 2. And when you work this out, you get an area of r squared units squared. And that would be your maximum area. And again, your height of your rectangle was equal to r over rad 2. And then your 2x here would be 2r over rad 2.